lecture series of operating system. In today's session, we are continuing with the topic process and thread management. Myself, Kunal Panchal, your instructor. In today's session, we are going to discuss two topics. One is introduction about thread, and second one is difference between process and thread. So let us discuss first what is thread. So as we have discussed in the previous session about process, so what was the scenario of process? So process is nothing but program in execution. Yes, that we have discussed in the previous session. Now, what is thread actually? So thread is nothing but a part of process, we can say. Thread is also called as lightweight process. Thread is also called as smallest element of process. There is no independent existence of thread. If process is there, then and then thread will come into the picture, because thread is a part of process. Yes. So if process is there, then and then thread will come. That thing you should keep in your mind. Okay. Now what is thread? So what is the definition? So if somebody asks you, what do you mean by thread with respect to operating system? So thread is the basic unit of CPU utilization within a process, we can say. Thread is nothing but basic unit of CPU utilization, and it is associated with a process only. Okay. So this is the definition of thread. Now as we discussed, in the case of process management, a process consists of various elements, we can say. Means each process is associated with one process control block, and each process control block contains 7 to 8 elements, or you can say informations are there. Yes, same way in the case of thread comprises of 4 elements. One is thread ID, second one is program counter, third one is stack, and fourth is nothing but register set. Okay, so what thread ID means? Okay, so these are the 4 different element we have in thread. So thread ID means what? As we have discussed in process contains process identifier. Same way, thread contains thread identifier, which helps to identify a particular thread within a process uniquely. So there is the significance of this field. With the help of thread ID, we can uniquely identify a particular process within with the help of thread ID, we can uniquely identify a particular thread within a process. Okay. Next field is program counter. As we have discussed in the process control block, same concept is applicable over here. As far as program counter is concerned, program counter is a special type of register which store the address of the next instruction to be executed. So same functionality is applicable in the case of thread as well. Now next one is stack. Stack contains certain memory, okay, and register set. So there are various types of sets, registers we have, general purpose register, special purpose register, index registers. So register sets are available, and general purpose registers are basically used for temporary storage. Or we can say register generally they are used for temporary storage. So these are the 4 different elements we have in each thread. So first of all, we have discussed the definition of thread. Second, we have discussed the thread contains which type of information. Now we are going to continue with the thread with its internal structure, we can say. So in early era, we had single tasking, or we can say single tasking operating system we had. Okay, in which a process contains a single thread through which we can able to execute only one task at a time. So in this particular figure, you can say you can see that in the left hand side, that block diagram is dedicated for single threaded process in which one thread is created. So that block contains that block considered as one process, and that process contains one thread. Okay, and each process is associated with one thread. So with the help of this arrangement, we can execute one task at a time only, not more than that. So what it contains? Single threaded process contains code section, data section, and file sections, as well as it contains stack as well as registers, as we have discussed in the previous slide. Okay, so a single threaded process contains code section, data section, and file sections, and thread has its own registers and stack informations. Okay, but in current scenario, we are dealing with multi-programming, or we say multitasking operating system, in which the operating system can able to execute more than one task at a time. How it is possible? So with the help of multi-threaded process that you can see in the right hand side of you, we have another block, okay, which is dedicated for multi-threaded process, in which there are different threads we have, and each thread has its own stack information and register information. Like if you can see, the first thread contains its own stack and register informations. Okay, second thread contains its own stack and register informations. Third thread contains its own stack and register information. Okay, and these three threads share the common code section, data section, and file sections. Means with the help of these arrangement, we can able to execute more than one task at a time, because each thread is responsible to handle each client request, or we can say each task. So that is possible in the case of multi-threaded process. So in the case of multi-threaded process, the code section, data section, and file section would be shared among the various threads within the process. Okay. Now, if you want to really see the process and its associated thread, there is one a software you can install easily from the internet, process thread view. So that software, once you install, okay, once you execute that software, it will show the current processes, and once you pick any of that processes, you can see in this particular figure I have selected the Firefox process. Okay, Firefox associated process I have selected, and once you double click on this particular selected process, because these are the set of processes. Now if you want to see how many threads are associated within this process, so for that you need to double click on this particular process, and once you double click on it, it will show look like this. It will show the associated threads. So you can see the first field, thread ID, means what as far as this process is concerned, how many threads are associated with this process. Okay, so with the help of thread ID you can uniquely identify a particular thread. Yes, so that we have discussed already in the thread structure. Yes, then second field is context switches. The last context switch is information. All these information you can view with the help of this particular software. Once you install and once you learn, you can easily observe these particular things. Not only this, but also as I told you, thread contains stack information as well. So you can see stack as well, stack information. So these are the stack address, stack base, stack limit, stack size. All these informations are available. So these are the informations which is associated with a particular thread as far as this single row is concerned, the selected row is concerned. Yes, and all these informations are associated with a single process which contains number of threads. Now, once you understood what is thread and significance of thread, now we are moving forward to differentiate the process and thread. So what is process and what is thread? So let us discuss the first difference. Process is also called heavyweight process and thread is also called lightweight process. As I told you earlier, thread is nothing but a part of process, obviously, and it contains only 4 information in it. So that's why it is called lightweight process and lightweight thread. And a process is also called heavyweight process. Why it is called heavyweight process? Because it contains 7 to 8 information within its process control block. So that's why it is nothing but heavyweight process as compared to thread. Now the second difference is process uses more resources and thread uses fewer resources. As we have seen in the previous slide, the block diagram of single threaded process and multi-threaded process, we can come to know that process requires more resources for execution because it contains more information within its structure, and thread contains few information, so definitely it requires, and it is part of process, so definitely it requires fewer resources as compared to process. Okay, now another difference is operating system interface is required for process switching. The interface is required because, as we discussed in the previous session, process has its own address space. Okay, so if you want to switch from one process to another process, the operating system interface is required. But in the case of thread, that interface is not required because different threads of a particular process share the same address space of that process. So thread switching would be faster as compared to process switching, as well as it doesn't require the interface of operating system. Yes, so that's why thread is more efficient, it is more faster as compared to process switching. Okay, another difference is blocking a process will not block another. Okay, because it do not share your address spaces. So if one process is blocked, it will not affect the other processes. It will work as it is. Okay, but in the case of blocking, a thread will block entire process, specifically in user level thread. One thread is blocked, the whole process means entire process will be blocked. That is applicable in the case of user level thread that we are going to discuss in the upcoming session. There are two types of threads. One is user level thread and second one is the kernel level thread. So in the case of user level thread, blocking a thread will block entire process. Now the next difference is context switching is slower as compared to thread because it uses different address spaces, and whereas in the case of thread, context switching is faster as compared to process because it uses shared address space. So this is self-explanatory sentence as I told you in the previous slide. Now the next difference is individual processes are independent of each other and threads are part of a process, and so they are dependent. Yes, because processes do not share the same address space, so they are independent in nature. But in this case, the different threads share the same resources. Okay, so that's why the threads are dependent. Okay, so this is all about the difference between process and thread and the concept of thread. I hope it was clear to you. Thanks for watching this video. See you in the next one.